Analytic views follows star schema model in HANA. Basically, these are OLAP objects wherein we join our transaction information with our master data. So when we say master data in HANA terms, it's going to be attribute views. So here in Analytic View, we are going to join our transaction tables with different attribute views to form our OLAP object or star schema model, or we can also call it as multi-dimension modeling. And when we say star schema model, what is the definition of star schema model? Star schema model says a fact table is surrounded by dimensions. So when we say fact table surrounded by dimensions, so basically we are going to have only one fact table in Analytic View, or while we are creating Analytic View, we can only have one fact table in one Analytic View. So what is the definition of fact table? So the fact table means the table that contains facts, or the table that contains measures which can be quantifiable, or which can be aggregated and analyzed with different perspectives. So in Analytic View, we can only select measures from one fact table. So even though we can add multiple fact tables in while creating Analytic View, but we can only select measures from only one fact table to the output. Now, what is our scenario to create Analytic View here? So as we discussed in introduction to SAP HANA modeling, this is the data model we have. So wherein we have orders information as well as payments information. So if we look at this image here, so we have orders information in orders table as well as order details table. So table contains our header order information, and then detail table contains line item level information, which means how many products has been ordered in one particular order, and what was the quantity of each product, what was the total amount for that particular product. So which means different lines. So one order can be placed for multiple products, or we can also call it as multiple items. So we have our main information here. Along with that, we have customers table, which says who is the customer that has placed that order, and we also have who is the salesperson responsible for that customer and where is he located in office table. Along with this additional information, or we can also call it as master data, we also have products information. Like in order details table, we are going to have what is the product code, but here we have what is the product name, or who is the vendor, or what is the MSRP price of that product based on the product code. And we also have time dimension here, or we can also say time master data, because if we look at our image, it might not be fully visible, but we have like when was the order placed, like ordered time, or when is it customer expecting, like required date, or when was the order shipped, like shipped date. So we have all those dates. So let's say if customer wants to, or if business wants to analyze their orders by different time elements like year, how many orders has been placed in this particular year, or in this particular quarter, or in this particular month. So that can be easily analyzed by joining our time information, which gives what was the year, month, quarter, date based on the actual date we give. So now we see how to create an analytic view based on all these tables. So let's go to our HANA system, where we have all these tables available in our SAP student schema. We go here into tables. So we have all the tables like orders, order details, and then customers. Then we have products table, product table here, and then we also have time information. Time information can be automatically generated in HANA, so that's why we don't have timetable here, and we can directly pick the timetable from sysbi schema here. We go here, we can see the time information stored in m underscore time dimension. So in a separate video, we'll cover how to generate time data and store it in these particular tables. Anyhow, for now, we are going to use time data from this table. So before we go ahead and create our analytic view, we need to make sure we have required dimensions. So when we say dimensions here, we need one dimension for customers by using customers table, employees, and office table, and then one for products, one for a date dimension. So each dimension is referred as attribute view in HANA. So we have already created the required attribute views here under our SAP Student e-learning package. Why? Because all the modeling objects we create in HANA are grouped as packages. So before we create any modeling objects, we need to make sure we have packages. We have the required package created in HANA. If we don't have package created, we can go ahead and create a new package by right clicking on any package and then say new package. We can create a new package. For now, we have our package. The next step is going to be create an analytic view. So to create an analytic view, right click on package, say new, and then select analytic view. So here we need to give what is the technical name for our analytic view. So I'm going to specify it as AN underscore. AN says it's an analytic view, and then orders underscore sales. Okay, so once we give the technical name, by default the same technical name will be copied as a label, which is a description. We can leave it as it is, or if we want, we can modify it. And then next one is view type. Anyhow, we want to create analytic view, so leave it as it is. And then next one is copy from. So if we want to copy the entire structure from a different analytic view that we already have in the system, then we can choose this and then say browse and select that particular analytic view. But anyhow, in this case, we are going to create a new analytic view. So click on finish to get into a design area of an analytic view. So here, this is a design screen to build an analytic view or to create an analytic view in HANA. So we have three different sections here. One is semantics. So this particular section gives a overview about that object, like what columns has been selected for output in this area, and then what are the columns that are coming from the attribute views used in this section, used in the analytic view in this area. And we also have properties of this particular analytic view, and then we can also see were there any hierarchies used, and then we can also see was there any parameters, input parameters or variables created in this section, which we're going to see in separate videos. In the data foundation, this is where we add our fact tables. So in our case, the fact tables are orders and order details. So we'll go to our SAP student schema and then drag and drop the orders table here. So we can see drop elements here, right? So we just have to click on that, keep dragging, and then drop it here. So we already have this object. The other way of adding objects here is once you move our mouse over to this name data foundation, and then we get a plus symbol here, just click on that, add objects, and then we can search for the table. So our next table is order details. So order details, and then we can see here we have table. So select the table, click on OK. So whenever we use that search option, we need to make sure that we are using table from the, we are selecting table from the right schema, because sometimes we might have same table in different schema. So we need to make sure we are picking from right schema. So once we have the tables here, the next step is if we have more than one table in data foundation, we need to define the join condition. So here we have order number as a common field. So join them, and then our join type we can define here, which is going to be inner. So once we define join condition, we can also define cardinality, because this is our header orders information, and then here we have orders details. So which means for one record from orders table, we can have multiple records in order details. So we are going to define cardinality as, so we need to select the join, and then we can see cardinality here. We are going to define cardinality as 1 to n. So one record here can contain multiple records here. So once we define the cardinality and then join type, the next step is selecting the columns required for output. So we need order number, and then we need order date. Let's say we'll pick ship date, and then we are going to pick customer number because we have to join our customer attribute view to pick all the relevant additional information for customers. And then we are going to select product code so that we can get all the products information, and then quantity ordered, price for each quantity. If we want, we can also go for order line number. So we have already selected the required columns. The next step is going to be get into star join. So this is where we are going to add all our dimensions and all our attribute views and define join conditions. So this structure is based on the columns we have selected from data foundation area. So once we come to star join, the next step is add all the attribute views. So we have our 3 attribute views here. Let's go ahead and drag and drop them. So we have customers, products, and then time. Okay, so the first one is customer. So we have customer number. So let's join that based on our customer number. And here, basically we add our dimensions or attribute views to get additional information. But because of that, we should not lose our important data which is residing in our data foundation layer. So that's why we are going to define join condition as left outer, which means we want all the data from left table and the available data from right table, which is our attribute view. So in the same way, we are going to join products attribute view to our data foundation. So we have product code, join this with product. So if you remember, we have additional calculated column here, which is product number. So if we can create one additional calculated column here, then we should able to join based on integer data type instead of varchar. But joining on calculated columns cannot be performed at analytic view, but the same thing can be performed at calculation views, which are more complex and more flexible when we define any models. Now, so here also we are going to define join type as left outer and then cardinality as n to 1. The last one we have is our time dimension. Let's pick that. So we are going to add this to our order date to know in which year the order was placed or in which quarter, which month. So if you want to know all those details, we're going to join that and then define join type as left outer, cardinality as n to 1. So once we define this, we can auto arrange using the auto layout option here. So once we click this, it's going to automatically arrange it for us. So once we define this, we can go to semantics, and if we use here, we should be able to see what are the columns coming from a data foundation, and then what are the columns coming from all the attribute views we have used in star join. And we can also define additional settings here, which we are not going to discuss now. Once we add all the fact tables required and add all the attribute views required here, the next step is go ahead and validate. Okay, so the problem here is we haven't defined any measures. So we can define measures here using the type column available here. So our measures are going to be quantity ordered and then price for each. So these two are going to be our measures. So make them as measures, and the remaining three columns are going to be our attributes. So now we have defined what columns are our measures and what columns are our attributes. Now we can go ahead and validate this. Now you can see it's completed with warnings which we can ignore. Now we should be able to activate this, and we can see it's completed successfully. So we don't have any warnings at all. Now once the object is active, we can go ahead and do the data preview on top of it to see whether we are getting any data out of it or not. So with this, we can say we are getting data out of it, and we can also able to quickly analyze that data. Let's say suppose we want to see how many orders has been placed in each year. So we have year column here which we'll add into label access, and then we also have order number. We add it here. By default it's going to take it as count. So now we know that we have orders placed in 3 different years, and this is the quantity of orders in each year. And if you want to know by product code, let's say how many orders has been placed by different product code. So instead of year, we can use our product code, which is here. Just drag and drop into label section, and we can see the different product codes and the number of orders has been placed, and we can quickly analyze, identify, okay, this particular product which is S18332 has more number of orders than other products. So this is how we can create Analytic View in HANA, and how we can even analyze data at HANA level instead of creating a reports and then checking whether we are getting data or not. So in the next videos, we are going to see how to make use of the advanced options we have in HANA and the star join, like calculated columns, restricted columns, input parameters. We'll see how to create those things, and we'll also see how to create hierarchies at attribute view level and how to access them through analytic views when we build any reports on top of it. Thank you for watching. Have a good day and happy learning.